There are other minor intrusions, and this is in fact a small sill which appears beneath the basal sill on coal seam cliffs. It may actually be connected to it, but you can't actually see whether it is or not. Next. And there are a couple of small dikes, one of which may be related to the younger sills and dikes of Lentimble, because it appears to cut through the basal sill at Lentimble. Next. Looking at the photography, I will look again at the same series of sills. Next. This is the, what I did was a lot of point counting of both the chilled marginal rocks, which are very much porphyritic, with phenocryst, plagioclase, pyroxene, and olivine, and they vary between the different sills. Some are very much olivine rich, others are less so. Next. Scarp capping sill is in some ways completely different from all the other sills in the Theron Mountains. It's generally a medium-grained quartz dolerite with plagioclase, clinopyroxene, and micropegmatite as the main minerals. Iron ore, phaletic olivine, apatite, and zircon as common accessories, and hornblende, biotite, and chlorite for alteration. Next. It has clinopyroxene marginally replaced by granular phalite and a zircon needle with a slight halo effect penetrating into hornblende. Next. The different phases of intrusion. On the right side, you can actually see the contact of the first and third phase sills in Marrow Cliffs, with the porphyritic third phase sill showing a clear chilled margin against the other one. Next. And this shows the variation between the different sills, with the first phase generally having a micropegmatite, but the rest of them don't have micropegmatite. They're very much olivine enriched. Next. Looking at the basal sill of Lentimble, which may be equivalent to the third phase in sorry. In Marrow Cliffs. It is very unusual because it actually has a number of xenoliths in it, which are not common in the sills, but they do occur in this particular one. Next. And they do have some strange things associated with them. Next. There is a clear chilling of the dolerite against the margin of the xenolith. Next. And even this can be seen even in thin section, where in fact it actually looks as if there is actually a flow structure around the siltstone of the xenolith in the marginal dolerite. Next. Most significant thing, though, is that the dolerite has actually been changed from its normal colour to very much a green, highly altered dolerite. And on the joint planes, there are veins of andradite garnet surrounded by boxwork calcite. Next, which you can see in this specimen here. The andradite was determined, identified by X-ray diffraction. Next. The layered sill, Jeffreys Glacier is very much an orthocumulate, and the mafic layer through the middle consists of olivine, orthopyroxene, and clinopyroxene with interstitial plagioclase. The normal dolerite below the mafic layer, plagioclase is much more common, and it's not interstitial as such, it's more as discrete crystals. Next, and the proportions you can see of both the layered sills in Marrow Cliffs, which is the Z481 ones, and in Jeffreys Glacier. Very rich in olivine. Even the normal dolerite is fairly olivine rich, with 2 pyroxenes and plagioclase. Next, this is the layered sill of Marrow Cliffs. The lighter layers are very much single nucleation center with plagioclase, orthopyroxene, and clinopyroxene radiating from it. And in the mafic layer, you've got olivine, orthopyroxene, and clinopyroxene with some plagioclase interstitially. Next. And this is simply a comparison between the layered sills of the Theron Mountains, which are the Z497 ones and the Z481 ones, with other layered sills that have been found in Antarctica. And you can see that there are a lot of similarities between them. But the main difference is actually that the Theron Mountain ones are much more olivine rich than the rest of the Antarctic ones. And Palace 1 is the Palisade Sill in New Jersey, which is also olivine rich. Next. Looking at the major sills of coal seam cliffs, the middle sill, which is the ones in the top of this table, are very much micropegmatite quartz dolerites with a lot of micropegmatite, and any olivine is very much phaletic as opposed to phosphorite. So it's the iron end of the olivine range rather than the magnesium range end. The basal sill, in contrast, has no micropegmatite, and it has quite a lot of olivine throughout. Next. Other minor intrusions are variable. 1 or 2 of them contain some micropegmatite, and some of them actually contain olivine as well, which is a little strange, but it may well be that the olivine in those is phaletic, although it's not identified as such in this table. Next. There are hydrothermal veins in some of the thin sills. This is one in coal seam cliffs. Next. And there is a minor sill above the scarp capping sill, which has intergrowth of orthopyroxene and clinopyroxene. Next. And sorry about the writing, but I had to rejig this one at the last minute because I realized in the typing of it, I'd actually made an error. And this simply shows the general mineralogy of the major sills of the Theron Mountains, namely the scarp capping sill, the middle sill of coal seam cliffs, both of which are quartz dolerites, the basal sill of coal seam cliffs, and the basal sill of Linton Bluff, which are fairly rich in olivine, and the layered sills of the mafic layers and the felsic layers, which are also fairly rich in olivine. Next. Looking at the geochemistry on my right notes. Next. Major, the 97 specimens were analysed for 10 major and 14 trace elements using a Philips PW1212 X-ray fluorescence spectrometer, which meant that the samples ground to powder, compressed to 3.2 centimetre pellets under 15 tons pressure, and then fed into the machine. Duplicates were checked to make a check on sampling errors, and this table shows the 3 specimens which were duplicated effectively, and showed that the sampling errors were relatively small. Next. Ferrous iron was determined by titration with ferric sulfate, and then ferric iron was done by subtraction from total iron oxides. Again, duplicates were made to check on the accuracy. Next. Oh, sorry, go back one. H2O was determined by drying at 110 C and total water by the Penfield method. And don't ask me what the Penfield method is, because it's 50 years since I did this work and I've not been involved in geochemistry since then. And then CO2 was done by acid-base titration. And again, the total water determinations were duplicated to check on the accuracy. Next. The scarp capping sill was collected much more than any of the others, largely because it was so widespread in its occurrence, and shows relatively little variation. It's fairly high in silica, in titanium, total iron, and several trace elements, but it's low in alumina, magnesia, and lime, and fairly low in chrome, nickel, and strontium. Next. And that simply shows the variation in the trace elements. I've not included trace element analyses of the other sills because I didn't want to overload you with too many tables of figures. And I don't expect you to be able to answer questions on these tables at the end of this talk. Next.